This video is going to review your assignment called Punnett's Square Practice. Notice at the top you have 5 Jamboards, right? And so again, you can scroll through each board by clicking on the arrows up here. And so on Jamboard 1, it says directions for each of the genotypes. Remember, we learned how genotypes are the combination of alleles or letters. So for example, capital A, lowercase a, or 2 lowercase a's. For each of the genotypes below, determine what the phenotype or the physical appearance would be. The first one has been done for you. You can type or draw your answer. If it's easier for you to write it down, that's perfectly fine too. Just add your work to your assignment. So here the example says purple flowers are dominant to white flowers. And from what we learned last time, we assign the capital letter for dominant traits. So if I see 2 capital P's, right, it will be a purple flower. A capital P and a lowercase p, this one is hybrid or heterozygous. And since it has at least one dominant allele or letter, it will show the dominant trait, which in this case is purple. So it will be a purple flower. 2 lowercase alleles or letters will give you the recessive trait, which in this case is white flowers. So go ahead and do the bottom, the next 2. You've got either hairy knuckles are dominant to non-hairy knuckles in humans. And then here, bobtails in cats are recessive. Normal tails are dominant. So notice this one's a little bit different. Board 2, directions for each of the following. Write whether it is homozygous dominant, heterozygous, or homozygous recessive. Board 3, we are going to go over a question here. So a female rabbit is heterozygous. The male rabbit is homozygous recessive. Write the percentage or ratio of possible phenotypes and genotypes of their offspring by using a Punnett square. And so on the left-hand side here, we have percent of possible genotypes, right? Here are the genotypes here, and then you are going to type the percent. Here it says percent of possible phenotypes, black fur and white fur. We're gonna write the percent here. And so notice here in gray, it says place the alleles for the male parent below. 1 allele on each line, 1 letter on each line. On the left-hand column, place the alleles of the female parent on the side, 1 allele for each line. So remember from last time, you put the parent alleles outside of the box, and inside the box is when you combine these alleles. And so here, if we're looking at the male parent, it says the male parent is homozygous recessive. So if the male parent is homozygous recessive, we know that the prefix homo means same, and the letters we're using here are R's. And so here you would put a lowercase r and a lowercase r. The female rabbit is heterozygous. And so then you would put a capital R and then a lowercase r, right? Since it's heterozygous or hybrid. And so you would fill in the genotypes for the offspring. I'll do the top left one as an example. So we will have 1 allele from mom and 1 allele from dad. Okay, so again, I'm combining the 2 alleles, 1 from each parent, right? And so you guys were pretty good at this. So I'm going to stop there and give you a chance to complete that yourself. So same thing, the female kangaroo is heterozygous. The male kangaroo is heterozygous. Figure out the phenotypes and genotypes of their possible offspring using a Punnett square. And so let me know if you need help figuring any of these out. But remember, when you're figuring out the percent of possible genotypes, say for example, you have 1 out of 4 boxes, right? For the genotype, that would be 25%. 2 out of 4 is the same thing as 1/2. That would be 50%. 3 out of 4, 75%, right? 4 out of 4, obviously 100%. And so just remember that. For percent of possible phenotypes, you're looking at, again, how many boxes out of 4 are showing either long legs or short legs for this. Slide 5, this is saying having a widow's peak like Wentworth Miller is dominant. Not having a widow's peak like Rihanna is recessive. If Wentworth is capital A lowercase a and he and Rihanna had children, what are the possible phenotypes and genotypes of their children? And feel free to show your work if you need to on this Jamboard. All right, so hopefully that was helpful. Let me know if you have any questions.